All right, this is the last video for Unit 1. We are on the back of your end of course review in the last two topics. Solving for an indicated variable. Basically, these are the problems where there might not be any numbers in them at all, and you're asked to solve for a specific variable. So what that means is you need to isolate the variable, and basically your steps are going to be solving like you would if there were numbers in it. It's just that you can't actually answer the problem. So, first example. We are going to solve for x, and the equation is y equals negative 4x plus 16, so we want to get the x by itself. So the first thing that we would do would be to subtract 16 from both sides. So y minus 16 equals negative 4x. And the deal here is that we can't actually subtract 16 from y, so it's just going to stay y minus 16. Is that focused? Okay. And then we're still trying to isolate the x, so we need to divide both sides by negative 4. So that's gone. So we have x by itself, and it's y minus 16 over negative 4. And that's your answer. All right, on this one, we're solving for L. So the first thing we need to do, and you have a couple of choices. You could distribute the 2, but I'm actually going to start off by dividing by 2, because that will cancel that out. So we have to divide that by 2. So now we have P divided by 2 equals L plus W. We're solving for L, so we need to get rid of the W, and we do that by subtracting W from both sides. That disappears. So L is by itself, and we have P divided by 2 minus W. And that would be your solution. So that's solving for an indicated variable. All right, last topic in Unit 1 was solving exponential equations, and I really like this. This is just kind of like a little bit of a logic puzzle, but they have to have the same base in order to solve, and then we're going to make an equation out of the exponents. So once the base numbers are the same, we can pretty much just ignore them. We don't need them anymore because what we need to do is solve the exponents. So on here, this is a 3, this is a 9. The only thing that we can do is we can write larger numbers as smaller numbers. So I could write 9 as 3 squared. And if I did that, then both of my base numbers are the same. So this one doesn't need to change. This, I've replaced 9 with 3 squared, but it was 9 to the x. So now it needs to be 3 squared with the x. So this isn't important anymore, and what we're going to do is make an equation out of the variables. So x minus 8 equals 2x. Subtract x from both sides, and negative 8 equals x. All right, next one. All right, this one you might have to do a little bit of thinking. This one's a 4, and this one's a 1/4. Hopefully you remember from Math 8 that we can change fractions into numbers that have negative exponents. So I'm going to rewrite 1/4 as 4 to the negative first. And then this one already had an x minus 18 on it, so I need to fill that back in. I can't just lose that. This one over here was already a 4, so the bases are the same. This exponent is 4x plus 8. So now I'm going to make an equation out of the exponents. So 4x plus 8 equals negative x plus 18. All right, I'm going to add x to both sides. So I have 5x. I'm going to subtract 8 from both sides, so that gives me 10. Divide both sides by 5, and x equals 2. And that's the solution. All right, that covers Unit 1. So now, if you will go to the second sheet that I gave you, I think at the top I said something like practice on your own. I'd like for you to work on that, and I will have the answers for you on Edmodo tomorrow. All right, thanks for watching. Move on to Unit 2.